Hey, good afternoon, Geometries period 3 and 4. It's Mays coming to you live from room 308. It's Tuesday, the 21st of April, and I still need a haircut. All right, what I would like to do today is I'd like to put up a problem here from your Chapter 10 quiz. It's problem number 18, as you should be finishing Chapters 10, Section 10.1, 10.2, and 10.3. And the problem that you will probably face in the near future on an opportunity to demonstrate your vast knowledge and superior skills might look like this. Now, this is problem 18 on page 552. It's from your Chapter 8 quiz. Problem number 18, it looks like this. There it is, problem number 18. All right, so they draw you this beautiful picture of a circle, center P, circle P, okay? And this is what they give you. They give you that AC is equal to FD is equal to 30. Well, let's go find that. Well, AC is a chord. Notice that point A and point C are on the circle P. And they tell you that FD is equal to 30. And notice points F and point D are on the circle. That makes AC and FD both chords of circle P. Now, the cool thing about this is they are congruent chords. They both have length 30. That might be useful. They also tell us that from P to G, from the center to point G is x plus 5. From the center to point J is 3x minus 1. Notice that those are perpendicular distances from a line to a point. That is the shortest possible distance you can get between that chord and that center P is the perpendicular. Same deal there, all right? Valuable information. All right, now that's what they give us. Now, what else can we gather? What else can we gather? Well, we've been staring at it. We know that BE is a diameter of circle P. It contains the center. It's a diameter. It has endpoints on the circle and contains the center, diameter. We also know those two chords are perpendicular. Yes, they are perpendicular. So I know that AC is perpendicular to diameter EB. I also know that PJ is perpendicular to FD. Now, what is the significance of that? Well, if I was to extend PJ through the circle, it too would be a diameter. So therefore, I can also think of that PJ as a diameter being perpendicular to the chord, just like the top one. All right, so I think I have a game plan for this. So I'm going to go over here and gather some theorems. I think these two theorems are going to help me out. Equidistant chord theorem. In the same circle, or in a congruent circle, two chords are congruent if and only if they're equidistant from the center. But what happens if we use the converse of that? In the same circle, or in congruent circles, equidistant from the center, two chords, same length they must be. All right. And then I can use the perpendicular chord bisector theorem. In a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. All right? So between those two theorems, I think we got this, or the converse of one of them. All right, so what can we do? Well, let's go over here. I can say that x plus 5, and this is going to be a 3x minus 1. And if this chord is perpendicular to this diameter, that means that this bisects. That means this is a 15, and this is a 15. And by the same theorem, I can go down and say, okay, that's also a 15. And from E to J is also 15. I'm not going to put that in there, but anyway, it would be 15 also. All right, so now I can say that x plus 5 is equal to 3x minus 1. So let's do that. X plus 5 is equal to 3x minus 1. And then I can say that 2x is equal to 6 and x is equal to 3. So that makes this an 8. And that makes this an 8. 3 times 3 is 9. Minus 1 is definitely an 8. Okay? So look at this. Look what I have. I have something phenomenal. If I draw a segment from A to P, I have constructed a radius. I have gone from the center of a circle to a point on the circle. That would be a radius. And in the process, I have constructed a beautiful right triangle. And some of you are jumping up and down going, oh, Pythagorean triple, I know what the hypotenuse is. I'll bet you do. But if you don't, If you don't, we can always take this information here, and I can say that 8 squared plus 15 squared is equal to r squared, and 64 plus 225 is equal to r squared, and 289 is equal to r squared, and of course we all know the square root of 289 is equal to 17. So the radius of this circle is 17. We found it. Now, I'm sure there are other ways to accomplish this task, but that's just the way that came to my mind first. So that's what I did. All right, so that's problem number 18 on page 552, part of your chapter 8 quiz. Okay, well, I'm glad we got that one done. All right, so we had a little meeting with the Geometry World. We're going to finish chapter 10. We're going to augment it with some CUDA software. We've got some worksheets out there for you and some additional assessments. These checks for comprehension, we're going to call them. And we're going to do chapter 11. So between chapter 10 and chapter 11, that's pretty much going to finish us out. And that's an ambitious schedule, but I think we can make it. You guys are kicking, you're doing great. Thank you very much. And for those of you that aren't, you're still kind of there. So I'm happy about that. Overall, geometry, you guys are doing a phenomenal job, and I'm very pleased. So let's stay on it, though. Let's stay on it, and let's get chapter 8, continue to roll that. Some of you guys are doing exceptionally well. You're already up into like 8.5, or I'm sorry, 10, 10.5, 10.6 area. But anyway, don't get too far ahead of it, though. So that's your chapter 10. That's problem number 18 from your chapter 10 quiz. And you might see something like that. And of course, how am I going to foul you up? Well, you remember when I showed you that little x plus 5 and 3x minus 1? What happens if that x turned into like 10 plus a half of an L, where L once again is the first letter of your last name? That would give each of you a different radius. I think that's a great idea. Anyway, we'll figure out something cool like that. All right, that's all I got for you. So stay on chapter 10. You guys are doing a great job. And please forgive me if I get chapters 8 and 10 confused, because chapter 8 is where algebra is, and chapter 10 is where you guys are. But you're both in the same sections. All right, that's all I got, man. May's out.